Dear students, today's topic is the logic gates. The code is the ELEC-DIGIE-S3A. Before we discuss the logic gates, we go through some understanding some basic terminologies used in logic gates. First, logic. What is logic? Logic is defined as the science of reasoning. It describes what statements follows from other statements. In logic, all statements are either true or false. There is no room for maybe, perhaps, might be, maybe, or might be, perhaps kind of things. Therefore, to express true or false conditions, we need only two variables or symbols. Hence, the binary number system, in which only two variables or two numbers are allowed, 0 or 1, is the suitable binary number system for dealing with logical statements. Now, what is a logic gate? Logic gate is an electronic circuit which performs logical operations such as OR, that is plus, AND, that is dot, and NOT, that is dash or minus sign, called logical operators. That is addition, subtraction, and multiplication. It's called a logic gate. Means it's actually symbolic representation of an electronic circuit which performs these logical operations. Operation includes OR operation, AND operation, NOT operation. OR operation, what is OR operation? OR operation means it add to certain logical events taking place. We will explain that in a moment. And similarly, OR AND operation, NOT operation. So such arrangement, such electronic circuit is called a logic gate or a logic circuit. A logic network is a collection of logic gates interconnected in such a way that they perform specified switching functions: on, off, high, low, true, false, etc., and is also known as switching network. A basic logic gate like OR AND has the two or more inputs and one output, while for NOT logic gate, it has the one input and one logical output. Logic circuits are classified into two main classes. Number one, combinational logic circuits, CLC, we will be calling as them the CLC circuits, and number two, sequential logic circuits, sequential logic circuit. Now let's discuss these two circuits. Combinational logic circuit, CLC, is CLC or combinational logic circuit is one whose output at any instant of time is a function of its inputs at that instant of time only. For example, OR, AND, NOT, etc., etc. These are the examples of the OR gate, AND gate, and NOT gate. These are the called the combinational logic circuits. Now the sequential logic circuits, SLC, a sequential logic circuit is one whose output at any instant of time is a function of not only of its inputs at that instant of time, but also of the past inputs which have been removed. A SLC or a sequential logic circuit consists of CLC, combinational logic circuit, and memory which stores the input data, for example counters. Now we will be using another term which is called the Boolean algebra or algebra of logic in the coming topics. What is Boolean algebra? It is an algebra where the variables are constrained, that is restricted, to have only two possible states or values of on or off, true or false. The variables are bi-valued, means two valued they have by 0 and 1. Another term we will be using, truth table. The table which shows all inputs and output possibilities for a logic circuit. The events are taking place, there are input events and the output event. So all possible the combination possibilities of the input with the output relationship, that is called the table of truth or truth table. It is also known as the table of combinations of independent variables and dependent variables, that is input to the output. Now, logic equation. What is the logic equation? It gives a relationship between the input and the output variables. Now, we take the first example of the logic OR gate. We in this section S3A are going to discuss the understanding of the logic gates, and the proper logic circuit and logic gate will be dealing, or we will be explaining in the next section, which is S3B. So we just bring the certain examples here, and we'll be discussing to clarify the concept of the logic gates. Logic OR gate. Okay, this is not the normal OR we say this or that. This is the actually OR, capital O, capital R means logic OR gate. So along with, we are going to explain the logical statement examples. What is logic OR gate? It has two or more logic inputs and single output. Its output is 1. Now this is definition. What is a logic OR gate? It is a gate, its output is 1 if one or more or all inputs are assumed to be 1. That is the logic gate whose if its output is 1, if any one of its input is 1, then output is assume be equal to 1. That is mandatory, that is compulsory condition, that output is 1 only. It will be 1 considered if any one of the input is 1 or all of its inputs is equal to the 1. So example of the logical statement we take. Now let's take this example, beautiful example. Let's say the train will be stopped. This is a statement, a logical statement. The train will be stopped only when station arrives or emergency chain is pulled. So there are two conditions, two logical inputs, that the station arrives or emergency chain is pulled. For what output is the train will be stopped. So here we have A or B is equal to X. X is the outcome of that. Outcome is 1. Okay, so what we have, this arrival of the station, we say in this case is one of the possibility where the station arrives or doesn't arrive. So okay, it might have 0 and 1. If arrives means 1, it doesn't arrive means 0. Or emergency chain is pulled. Chain is again either it is pulled or not pulled. If it is pulled, it is 1. We will call it the true statement. If not pulled means 0 statement or false statement, and equal to X means station arrived means 1 and doesn't arrive means 0. Where A and B are two inputs of the two conditions of station and emergency chain, and chain is the output for the train stop or not. Now let us now say for variables A and B are station not arrived. Okay, so that is input statements. A for the station, A is equal to 0, which is false. Station arrived, A is equal to 1, true as defined in the statement. And emergency chain is not pulled, B is equal to 0, false. Emergency chain is pulled, b is equal to 1 is true as defined in the statement, while the output variable x that has the two states, train not stopped x is equal to 0, train stopped x is equal to 1. So now we will, so you understand that in logical operations what we have, there are certain number of events at the input which cause the output, which is single event. Okay, a number of input statements may be 2 or more than 2, minimum we should have 2 statements, and then output would be more than 2, 1 statement, but the input maybe have more than 2 statements as well. Okay, now let's see, let's take the truth table, which shows all the combinations of A and B. In this case we have 2 inputs, A input and B input. These are 2 inputs and 1 output, which is x. So we have already defined that A is a binary variable which is bivalued, means it may have only 2 values, either 0 or 1. Similarly B and similarly x, 0 or 1, 0 or 1. So how many combinations we could have if we have the combination with the A, B and x relationship, that A is 0 and B is 0 and x is 0, A is 0, B is 1 and x is 1, depending upon its operation, which is in this case A or B is equal to x, or get, or operations we are applying. So here we have got the A will have 2 combinations, two values, variable values, 0 and 1. 0, that means A, we have assigned that for the station arrived or not arrived. Okay, in the statement it is given that station will arrive if either the station will arrive, sorry, the train will be stopped. This is the first, the outcome of that. The train will be stopped if either the station arrived or emergency chain is pulled. So these are 2 true conditions that we has to be met. So in this case, let's say that the station is arrived or not arrived. A will have 2 possibilities, 2 values. Not arrived, we assigned 0 and arrived 1. Similarly, in this case B, emergency chain is not pulled, 0, and chain is pulled, 1. Station, the train stopped or not stopped. Not stopped is 0 and stop is 1. So let's now analyze this these statements. First, station not arrived, emergency chain is not pulled. So the outcome should be the train not stopped. So it is, according to statement, it was that if the station, the train will be stopped if the station arrived or emergency chain is pulled. So in this case, this statement is true because neither the station arrived nor the chain is pulled. So train is not stopped, train is moving. So that is a true statement. If we would have here, the train would have stopped without these, that is the station not arrived and chain is not pulled, that would have been false statement. So but anyway, the values which we have in this case, the station not arrived, chain is not pulled, train didn't stop. So that is first part. Similarly, station not arrived but chain is pulled, train stopped, that is a true statement. Station arrived, chain is not pulled but train is stopped, that's true. Station arrived, which is 1, chain is also pulled, 1, train is stopped, that is true. So these are the, you can see the how logically we assess or analyze a statement. Then we will be applying it to the circuitry as well as a switching circuit. We will see that. So that is the truth table, which is, so if we apply the OR gate operations, which is suits to these statements, 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0, 1 or 0. We normally say 1 plus 0 is equal to 1, 1 plus 1 is equal to 1. 1 in a sense that this is the statement wise, that is true, this is true, this is true, station arrived, chain is pulled, train stopped. We have assigned that one. Okay, so that's the part which is the we come with the truth table. Now one more few tips for the how we memorize or how you remember these combinations. So very simple rule for that. If there are number of variable inputs, okay, let me write those. So here we have the, let's say the n is the total number of these combinations, okay, that is the for one particular a event or a input. So how you find the how many number of rows you are going to add, how many number and which numbers. So what you will have, the small n is the number of events, the number of inputs. If there are two inputs, n is equal to this, small n is equal to 2. So the number of combinations for the a will be 2 raised to power 2, which is equal to 4. Okay, so one particular 4 for a, 4 for b, and 4 for c, x. So output. So here what we have, then how to arrange them, that is 0 should, which should come first. Very simple order, you just follow this. There are total number of 4, take the half of it, make half zeros, 2 zeros, the half of the 4 is 2, so 2 zeros and 2 ones in this case. The next b, what you do, take again the half of that, 2, that is the 2, 1 0 and 1 1, 0 1 0 1. That is the input combinations. The output will come obviously with the relationship operation or relationship of these two, a and b. So that's how very simply you can make this table of the combinations of the input and output variables. If you, another example you take, if n is equal to 3, small n is equal to 3, so total will be combination 8. So in that case will be half of the 8 will be 4, the 4 zeros and the 4 ones, and so on and so forth. We will be here, then with 2 zeros and 2 ones, 2 0 and 2 ones. We will be very simply putting these the values of their input variables. Now let's move on to the next slide. The next is the logic AND gate. Logical statement, we give the example. What is the logic AND gate? It has two or more logic input and a single output, same as we have the, these are the basic gates. Remember, logic OR gate, AND gate, and the NOT gate. We will also discuss other gates, which are the derived gates, which are the obtained from the combination of these, all these three gates. So it has two or more inputs and one single output. Its output is 1 if all of its inputs are assumed to be equal to 1. So this is the particular condition for that AND gate. Example of logical statement, let's take that it is a statement that I will go to Islamabad if my friend goes with me and tomorrow's test gets postponed. That is the going to Islamabad is the outcome here, and the two here the inputs, the events if they took place, that if my friend goes and tomorrow's test gets postponed. So A and B is equal to X. A dot B, we normally write that, where A and B are the two inputs for the two conditions. Friends goes, that is equal to 1, and test gets postponed is equal to 1. So, and X is the output for to go to Islamabad. If you're going to Islamabad, that X is equal to output is equal to 1. So that would be the case. Now let us now say for the again the similar as we discussed in the OR gate. A and B are the two tagged as the friend doesn't go, A is equal to 0, friend goes, A is equal to 1, test not postponed, B is equal to, B is now the B for the B, test not postponed, B is equal to 0, test postponed, B is equal to 1, while the output variable is X not going to Islamabad, x is equal to 0. False, in a sense, we say the lower value. This will be a true statement if x is equal to 0, which is false, and the statement is true. Okay, in that case, going to Islamabad, x is equal to 1. It is the bit is that is the true value or the higher value. This is the lower value or defined whatever, not going to Islamabad. So as defined per statement, going to Islamabad, x is equal to 1. Now here is the table of the truth table, the combinations of these. Again, A is input, B is input. We have got friend doesn't go, test not postponed, not going to Islamabad, which is 0. Friend doesn't go, test is postponed, it is 1, but still unable to, because condition is that if friend goes, test is postponed, then we will be able to go to Islamabad. So in this case, not going to Islamabad, 0. Friend goes, but test not postponed. Again, there is a one event is taking place, but other one is not. So not going to Islamabad. But friend goes and test postponed means going to Islamabad. So that is the final one is the correct statement according to that. But these are also, all of the statements are true, because in nature that is the statement is true, because not going to Islamabad is linked with the friend is not going, so test is not postponed. If any of the statement is not being fulfilled, the conditions are not fulfilled, that means it should give you the 0. So these are statements are true, correct statement, I would call it correct statement, all of them. These statements would have been wrong if we would have got that friend is not going, the test is not postponed, but I am going to Islamabad, which is wrong. And this statement is wrong as per our initial statement. So this combination of the all A and B is shown by this truth table. That's now the table combination we saw that. Okay, now let's see how these the logic gates are symbolically represented. This is logic OR gate. So you will be drawing the logic OR gate in this manner. Okay, so this is this curve path, and that should be also curved, and the curve arrowhead kind of thing. One single line coming out. This is X. Input is A. It could be more than A and B. We have got two input in this case, two input OR gate. So we might have A, B, C, D, or whatever n number of inputs, but output is 1. This is the logic OR gate symbolic representation. Remember, this logic gate is nothing but it will be electronic circuit. It could be a transistor amplifier making the two-state switching, or it could be a diode. It could be any. You can make it from the discrete circuit as well. We will demonstrate in the next coming topic. So the logic OR gate is just a virtual representation of the electronic circuit. Just to simplify the things, we can't draw the whole bulky circuitry. So simply one big amplifier circuit is represented by some 2 or even more than 2-3 amplifier circuits might be having here, and they represent simply this symbol, which is that electronic circuit is performing certain operations. So we will be representing those operations only over here. Rest we know that what is at the back end. So the digital electronic base is analog electronics. Remember one thing, it is that all the amplifiers, the diodes, the ICs, integrated circuits, they do perform these logical basically perform the switching operations on and off, high or low. Okay, so that is the main theme or the concept behind it. So this is logic OR gate symbol. Next is this is the logic AND gate symbol. So we can see this is the D type symbol, little bit here elongated. So we have this one output X is equal to A and B, two inputs A and B inputs. Similarly we could have more than two inputs as A, B, C, D, and so on and so forth. Okay, so with this we reach to the end of the topic. Thank you very much for watching this video.